Hello, Algebra 2 class. In this video, I'm going to talk about Chapter 6, Section 5, the common log. So we've been dealing with logarithms, and logarithms are logarithms have a base. So log base 2 of 8 is 3, right? 2 to what power gives me 8? The answer is 3. Well, in general, there is a default base, just like you have square roots and then you have cube roots and you have fourth roots. But the default radical is square root. Okay, well, the default log, if no base is given, the default base is 10. Okay, so for instance, if you ever see a log and there's no base listed, that means that the base is actually 10. And by default, the base is 10. Um, so for base 10, there's two tables here, but that's because normally I would just show this and we'd fill it out. But I added this, or I didn't add this, but there's the filled out. Just looking at the filled out part of this table, if you have the common log of x, then the values of x, if you would have the common log of 0.001, that would be saying base 10, because there's no base listed, to what power gives you 0.001? Well, so you're asking yourself, if I pull up a calculator here, 10 to what power gives me 0.001? 10 to the negative third power is what gives me 0.001. So that's why this is negative 3. Log of 0.001 is negative 3. Okay? 0.01 is negative 2. 0.1 is negative 1. Log to what power gives me 1 would be 0. So 10, sorry, not log, 10 to what power? 0 is what gives me 1. 10 to the first power gives me 1. 10 to the first power gives me 10. 10 to the second power gives me 100. And then we get into the ones that might be a little bit more obvious. So 10 squared gives me 100. 10 to the third gives me 1,000. 10 to the fourth. It's pretty much the number of zeros is what the value is here, or the number of places to the left of 1. So see how negative 1, negative 2 is 2 digits, negative 3 is 3 digits. Okay, that's just the factor of 10, how 10 works. 10 is the default base if no base is written. That's the most important thing, and that's called the common log. So on your graphing calculators, there's a log button here. See this log button? There's no base. That is the common log. That means it's a 10, base 10. So if I would try any of these numbers, I would get what we got for the value. 10 to what power gives me 0.001? Negative 3. Okay. Log, let me try 1, should get 0. Log, let me try 100, should get 2. Okay, so that's what that button is, base 10. And you can always remember that because if you do second, the second log is actually 10, base 10 to what power, and this is the opposite of log is an exponential form. That's what's happening here. This is the exponential form of this log. Okay, so there you can be reminded that this is a log base 10 because there's a 10 right there. So I don't know if that helps. So we're going to do some real world application here. Fun. So the relative intensity variable r of sound in decibels is given by this function. R, that's the relative intensity of sound, is equal to 10 times log, with no base, which means log base 10, of I divided by I sub 0. I is sound intensity, and I sub 0 is the threshold of hearing. Okay, so let's do a problem. Example 1. The intensity of a whisper is about 300 times as loud as the threshold of hearing. Find the relative intensity of this whisper in decibels. So this is giving it in a decibel rating. Okay, well, if this is our formula, R is equal to 10 times log I over I0. Okay, I'm going to plug in 300 for I over I sub 0 because it says the intensity of a whisper is about 300 times as loud as the threshold of hearing. So I will equal 300 times I sub 0, or I over I sub 0 will be equal to 300. Okay, if I is 300 times as loud, then if you divide I over I sub 0, then you get 300. So that's all we have to do. Then we're going to use our calculator and this button here to do log 300. I mean, it's not all we have to do for the problem, but it's all we have to do for plugging in here. The only thing we have to plug in. We get 2.477. We're going to multiply that by 10 and get 24.7, or approximately 25 decimal points. Decibels. Decibels, I think is how you say it. Okay. Example 2 with the common log. The relative intensity R of a running vacuum is about 70 decibels. Compare the intensity of the running vacuum with the threshold of hearing. Okay, so in this case, we're actually going to plug in for R. We know the decibels. Okay, well, we have a 10, a times 10 over here, so we can divide both sides by 10 and get 7. We want to solve this for I over I sub 0. Okay, I over I sub 0 is what we're going to solve for. So think of this whole thing in both these problems as one variable, I over I sub 0. And we're solving for this. So how do we solve for this? Well, this is in log form with base 10 because there's no base listed. By default, it's base 10. So 10 to the power of 7 is equal to the variable I over I sub 0. Oops, I missed the sub 0 there, but it should be I sub 0. I have it there. So 10 to the 7th power, which actually you could use the second here to do the 10 to the 7th, is 7 zeros, right? So 10 million. Okay, so the intensity, the sound of vacuum is about 10 million times louder than the threshold of hearing. So that makes sense. Okay, so we're going to just solve a problem here. Solve x, 5 to the x is equal to 62. Okay, it's 5 to the x is 62. One thing we can do now with logs now that we have the common log is we can use the common log and some of the properties we've learned before to solve any problem. I know we could convert this to log and insert it, but I'm going to show you a technique if your calculator is not as sophisticated, or a technique they used to use before calculators became as sophisticated as they are. And that technique involves taking the log of both sides. So we're doing everything on this side inside a log and everything on this side inside a log. We can do that as long as everything's included on each side. Just like you can take the square root of both sides, or you could square both sides. Now we have a property that allows us to move this x in the exponent down in front. That's the power product, the power log, the product. I don't remember the name, but the property that lets you take the x and bring it down in front. Okay, so now we have x times log 5. This is common log of 5. Okay, and it's common log of 62. Okay, now I know the common log isn't nice for either of these numbers, but there is no log number that would be nice to go into both of these numbers. Now remember, log 5 is still just a number though. Whatever this log is, it's still just a number. So I could divide both sides by that. Okay, and that will clear out this solving for x and leaving log base 10, or common log of 62 over log of 5. So then at this point in my calculator, I can do log of 62 divided by log, just using the button on the face of the calculator rather than digging through menus, of 5. And I'm going to get a decimal value. But what's important to note about this, or the significance of this, is that this right here, what we just did, would be the same thing as finding the log base 5 of 62. Log base 5 of 62 will be equal to this decimal value. Okay? Essentially, log base 5 of 62 is equal to log of 62 divided by log of 5. Now, if you go into your calculator, if you have this, and not everybody has this, this is why some of the older calculators won't have this ability that I'm doing right now. So this is why it's important to know that if I'm trying to evaluate log base 5 of 62, I can just take the common log of the bigger number divided by the base. divided by the log of the base and get the exact same answer because of this algebra that's occurring. Okay, so hopefully that makes sense, because that's actually very significant in logarithms. And it also gives us the ability to actually change the base of any logarithm that you have. So we have a change of base formula that we can go from any base we want, or any base we have, to any base we want in general. Now, it's not common that you would want to change it to anything but the common log. Or there's actually one other one called the natural log. We'll get into that in a minute. But if I have log base b of x, I can write that as log base a, any number I need, like 10, and especially in this case, I'm changing it to base 10, of the bigger number, the thing inside the log, divided by log of that same base that you're changing it to, both the top and the bottom of the old base. It allows us to convert any log to any base. That's the change of base formula. So if I have evaluate log base 7 of 56, and I want to change the base of this, I'm going to change it to the common log, so I can use the calculator buttons on the face of the calculator. So this would be log base 7 of 56 is equal to log of 56 divided by log of 7. And these bases here, these a's are 10, so I don't have to write them. That's why they're not written. Okay, but I'm changing it to base 10 for both of those. And then on the graphing calculator, I can do log 56 divided by log of 7. Oh, I didn't end my paren, but that's okay. Doesn't need it. And you can see 2.07. Okay, so this is the notes for and there's some bookwork that I'll post. The notes for the common log, notes on common log, but most importantly, the two most important parts are that no base given means base 10, and that you can change any log to any base using this change of base formula. Okay, thank you and good day.